Thank you so much for joining me today. I'm glad to be here, and I'm looking forward to sharing this information with you. All right, so as Aisha mentioned, I am a sustainable ag specialist with the National Center for Appropriate Technology. And today I'm going to talk with you a little bit about turning our tables, the dirt on nutrition, health, and agriculture. So to give you a little bit of background, I want to let you know what my career background has been. So basically, I am a certified herbalist through the Rocky Mountain Center of Botanical Studies, a certified nutritionist through American Health Science University, a chef, and also a sustainable ag specialist. I got my degree in agriculture at Texas State. So today I want to talk a little bit about my shift in career from nutrition to agriculture. And this statement from Wendell-Berry really reflects why I made this progression. So there should be some profound resemblance between our treatment of our bodies and the treatment of the earth. We need to move our focus away from organs to organisms. For those of you all who don't know Wendell-Berry, he's a really amazing agriculturalist and agricultural writer, or just a writer in general, and somewhat of a philosopher. And his writings are very profound, and I suggest that you look them up if you haven't read any of his things. But basically, as many of you in the audience are aware, our internal and external ecosystems are breaking down, and there's an excess of disease and dysfunction that's happening in our societies, and it doesn't have to be this way. So from about 1998 till 2016, I studied and practiced herbalism and holistic nutrition in different medical doctors' offices, as well as at behavioral and academic achievement centers for kids with learning disabilities and autism. And during this time, the study of the human microbiome was advancing rapidly. And the human microbiota consists of the 10 to 100 trillion symbiotic microbial cells harbored by each person, by each of us. And that's primarily harbored in our GI tract. So in fact, there are more bacterial cells in our human bodies than there are human cells. So we are strongly overpowered by the microbiome in our body. So this research led me to promote gut flora health as the fundamental, as fundamental for overall human health. And little did I know at the time how similar the human gut and its microbiota are to the relationship between plants and soil microbiology health. But it wasn't long before I came to understand this relationship better. And so as time has progressed, another type of nutritional research is building upon those of the past. And the classical methodologies of food science and nutrition are being replaced with advanced omic analytical strategies. So these advancements allow the investigation of issues related to food unthinkable a few years ago. So this type of study is called foodomics, and this technology is going to help us investigate all the possible connections within and among foods, such as their composition and quality, their safety, their nutrient density, and the impact on an individual's health. And this is going to help improve the consumer's knowledge and allow them to improve their well-being, which is pretty amazing. And this study has advanced very quickly, and they're allowing us to move away from the individual one nutrient solutions that we've used in the past and understand the complexity of foods and what they can offer us when we use foods in their whole form, rather than breaking them apart into their individual nutrients. So in the foodomics research, you're going to see a number of different types of omic technologies. So metabolomics, transcriptomics, and proteomics, or nutrigenomics. There's a lot of different areas where we can look at the genes, we can look at its effects on metabolism, and lots of other things. So it's very advanced and it's very exciting technology coming online. So thanks to foodomics, we can now examine in greater depth by creating, we can examine our nutrition in greater depths by creating a food dome. And this picture on the right is a picture of a food dome. And what that means is it's the precise subset of chemicals to which each individual is exposed, and it defines that person's individual nutritional chemical food dome. And each of us has, a weighted subset of chemicals found in the food supply that we eat. And those are going to be influenced by our food supply, our personal choices, the geography of where we live, our culture, and the socioeconomic status that we have. So now using this foodomic technology, we can create food domes. And as you can see on the right-hand side, this is a picture of somebody's food dome. And you can see that, a huge portion of their diet is grains and vegetables. And so you can, yes.
Kara, sorry, you're not sharing your screen.
Oh.
We've been watching you.
Oh, well, that's too bad. Let's see here. I guess I brought the PowerPoint up and just did not share. Okay.
Even what you're just saying is very interesting.
Oh, thank you. Thank you. Okay, here we go. Here's the food dome. Now you can see it.
Perfect.
Yes. So I'll go back for 1 second here. Just so you can see, this is kind of the chart on the foodomics, just kind of an overview there. So you can see that picture. And then we have the food dome. So basically, we now can break our diets apart in very, very specific ways and look at all of the different nutritional components and many nutritional components that we never knew what they did before. So basically, we know that living tissue is very, very complex, and we know that all plants and animal-based foods have some kind of functional biological activity as well. And some food patterns obviously support human biological processes better than others, but the benefit or adverse effects of the biological activity can be really, really subtle. And so what we do know right now is we are only looking at 150 different nutritional components in our food composition tables. And those include like our macronutrients and our micronutrients. We've documented 26,000 plus chemical compounds in foods, but that 150 nutritional components only represents about 0.5% of that. So that means that 99% of the biochemicals, also called plant secondary compounds, present in foods are untracked by nutritional databases, and they're considered nutritional dark matter. And I love that term. I think it's a great term for it. But this nutritional dark matter or plant secondary compounds are also biologically functional. So we have a lot to learn. And I took this picture on the right at a seed farm that I went to in upstate New York last summer. And they were working with a university to develop these tomatoes that were really high in anthocyanin. And anthocyanin is a strong phytochemical that's a antioxidant in the body. And so they were looking to develop these and put them on the market and make them tasty, but also develop them as a healthier food for eating anthocyanins, which can have beneficial health effects. And they're definitely dark. So I love that example as nutritional dark matter there. So overall, the absence of information on these untracked biochemicals could be responsible for the inconsistency that we often see and the inability to reproduce published nutrition studies, and also for missing health effects. So it's really important that we start to learn more about these foods. Obviously, there's thousands of substances in the food matrix that we need to consider, and many of those things are also the microbes. The microbes have biological function as well. And foodomics can look at those microbes and how they interact with our foods as well. So overall, the methodology for interpreting information from the large amounts of substances that we take in to the body and foods needs further development, but we are well on our way, and I think it's very exciting, and I look forward to seeing how this advances as we move forward. So this picture on the right here is a picture of soil. Many of those little round things are sand, silt, and clay particles, but also the other things that you see that are kind of irregularly shaped or have tails and things like that are the microbes that exist in the soil, and they all work together to create healthy soil. So we know that the soil functions very similarly to the human gut, and plants and microbes produce enzymes that help them digest their nutrients and allow them to survive, and they work synergistically with one another. And in the human gut, it is the bacteria that produce most of the enzymes that break down our meals and allow us to utilize the nutrition from those foods. So the gut microbiome influences our health far beyond the gut and even influences our mood. So one thing that a lot of people don't know is that about 95% of serotonin, which is a neurotransmitter that is our overall feel-good neurotransmitter, 95% of that is produced in the gut. And so if we don't have a healthy functioning microbiome, we can't make that serotonin. We often will suffer from depression and other mental disorders as well. So the more I learned as a nutritionist, I began to wonder what kind of influence the soil microbiome and growing conditions have on the kinds of phytonutrients or the dark matter existing in the plants we eat. And as I researched the different foods and medicines that I could recommend to improve my clients' health, I found a common thread. And that was that by giving them recommendations on how to balance the microbiology in the gut and repair their intestinal lining, that inflammation and a lot of the other ailments that they were suffering from improved all throughout the body. And this was including, as I mentioned before, the behavioral and learning disorders that so many of our children struggle with today. In the center where I worked with the kids with autism, it was very profound to see, some children going from having low verbal ability, and when they would change their diet, they would go from maybe speaking 300 words to all of a sudden having a vocabulary of 500 and up, really growing and blossoming because certain foods in their diet were disrupting their GI tract and creating inflammation and not allowing them to flourish in their health. So as you can see, there's 36 trillion species on the planet and only 1 million are identified. And most of that lives in the soil beneath our feet. So that's pretty unbelievable. We have a lot to learn in that arena. So the main recommendations that I would make to my clients was to reduce ingesting foods, medicines, and chemicals that disturb healthy function of the GI tract. So that might include processed foods. Antibiotics can kill the microbes in the GI tract, herbicides and pesticides on the foods that we're eating. Things such as glyphosate, which I'm going to talk about a little bit more, have been shown to kill a lot of the gut microbiome. Refined sugars will feed the negative bacteria in the gut that we don't want, and food additives and different things like that also contribute to that. So in order to support the gut microbiome, and that picture on the right is a picture of all the different microbes that exist in the GI tract. So you can see there's a lot of variation in there and a lot of different, a lot of them in general. So to support the gut microbiome, it's important to increase cultured foods in our diet. So things like fermented vegetables and kombucha and yogurt and other fermented dairy products, or to take probiotic supplements that might be able to help increase the different species of microbes in your GI tract. So this, along with some other dietary changes, can help reduce inflammation, and reduced inflammation means that your gut can work more efficiently to uptake nutrients. And this is very important because a lot of us are operating on degraded GI tracts. So just to give you a little visual of what the GI tract looks like, on the right-hand side is a picture of a healthy small intestine where you see all the different microvilli there. The microvilli are the outward-facing components of the GI tract that absorb the nutrients that we take in. And those hair-like protrusions create so much surface area. Actually, if you were to take that whole surface area, it would be the size of a tennis court. So our absorption capacity is the size of a tennis court, which is pretty profound. So on the left-hand side, you can see a close-up view of that. So the little hair-like protrusions coming up off of those gut cells are the microvilli that you're seeing in that right-hand picture there. So when everything's working well, we have a nice mucus layer that sits on top of those gut cells, and that mucus layer harbors the microbes that help us digest our foods. Now, if we have a lot of inflammation in the gut, that mucus layer gets degraded and we don't have it, so we can't harbor the healthy microbes. As the microbes work in our system with the foods we are eating, they produce enzymes that then allow those gut cells to absorb things, to break down the foods and absorb carbohydrates, amino acids, and lipids. And then those are taken into our body and get distributed for health. Now, if we have a broken down GI tract, there can be little spaces that occur between those gut cells. We call it leaky gut or permeable gut. And what happens is undigested food particles actually get absorbed into our body, which is not supposed to happen. We're only supposed to have digested foods enter via carbohydrate, amino acids, and lipids. But when those undigested foods get into our body, those immune cells that you see there on the bottom begin to attack it. And that's when we can create food sensitivities. So those food sensitivities mean that our body starts to attack a food that we shouldn't have an allergic response to, but it shouldn't be in our system in that way either. So that's a little quick A&P lesson on the GI tract. There's a lot more to it, but just to give you a visual there. So I always recommended with my clients, when feasible, for them to choose the cleanest foods possible. And I would suggest that they eat whole foods, try to avoid refined foods, choose organic produce and meats as much as possible, wherever they could make it fit into their budget. And always, always, always avoid buying foods on the dirty dozen list, because these foods contain the most chemical residues on them. So even if they couldn't afford organic all across the board, these foods to always buy organic would be helpful. Additionally, they would avoid refined sugars and many other different things that we would discuss. But I quickly came to learn that these recommendations alone were definitely not doing the trick, and not everybody was getting better by making those changes. And so through food sensitivity testing and trial and error, we did elimination and reintroduction diets until we found what worked specifically for them. And this included kids, often very young children, and it wasn't easy, but they found relief and they were willing to do the work to feel better and also to behave better. But the question that I always came back to was, why are these children and these adults, why are their GI tracts so degraded? And, for children, especially, who should be resilient and fresh, they were struggling. So again, studies within my work as a nutritionist with kids with autism, we're often pointing to the use of glyphosate in foods. So those chemicals, the chemical Roundup that is used as a pesticide in foods. And I'm going to speak to that more down the line, but that is one of the culprits that was showing as a possibility for degrading the GI tract. So one of the things that we do know is that our foods have less nutrition in them than they did in the past. So if we were to take a bite out of an apple today, we would likely only get about 60% of the essential vitamins and nutrients that apple gave us 50 years ago. That's a big reduction. And why is that? And this is where the study of agriculture really entered into my life. And I began asking that question. And ultimately, today's agriculture has really focused on high yield over the production of foods that are nutrient dense and have robust taste and that type of thing. So unfortunately, we've lost about 1/3 of our arable lands due to soil degradation, which you can see in a picture on the left. That's pretty severe soil degradation and erosion. And these modern agricultural practices and this erosion is costing us about $8 billion annually in global economic losses. And I think that's actually really, I don't think that that's an accurate amount. I think it's much more than that. But the United Nations has estimated that we will have a complete degradation if we keep farming the way we're farming now within 60 years. And so nature is declining globally and at rates unprecedented in human history. And the pace of species extinctions is accelerating. And when we look at things holistically, we know that everything has its role. And so that's a very scary thing to think about. So overall, I began to educate myself on how this focus on quantity over quality in agriculture was having a detrimental effect on human health and the environment. And the more I studied, the more I wondered, how do we improve this? How do we make this better? And how do we stop, a lack of diversity from overtaking and inside of our GI tracts as well as on the land? And so, as you can see, we've got the soil erosion that occurs here when we don't practice having continual live plant root in the ground. When the soil isn't covered, it is going to cause soil erosion and degradation. And as that water travels over the earth, it goes into the rivers and the waterways and eventually winds up in the ocean, where we create dead zones that are not oxygenated and also greatly decreases the biodiversity in the ocean. The oceans are actually the greatest carbon sink that we have on this planet, and soil is the second greatest carbon sink. So we are not doing ourselves any favors by using these types of agricultural practices. So just as human gut function can be easily upset by disturbances such as antibiotics, so can the soil from chemical inputs. So this picture is basically from the Betty Ford Alpine Gardens, and they did a exhibit called The Secret Life of Roots. And this is a above and below ground view of what a perennial pasture from the bread belt would look like from, there's some still out there, but many of them have been tilled up, unfortunately. But you can see that in these systems, the nutrient and water cycle are going to work most effectively. And that's because, for one, the ground is covered with the plants, as well as there's deep roots in the ground. Those very deep roots in the ground are carrying carbon exudates down into the soil, which feed the soil microbiome, which in turn, that soil microbiome gives the nutrients back to the plants and allows those plants to be healthy. And so, unfortunately, this example is a far cry from the type of ecosystems that we have around us, and especially in agricultural environments. So basically, I believe that the degradation of soil microbiome through tilling these systems and using chemical inputs have greatly impacted the health of humans. And in order to improve the well-being of the planet and all its inhabitants, we really have to focus on soil health around the globe. Now, there is some research being done in perennial grain systems, so ways that we can farm grains that we don't have to kill annually, that we can harvest from year after year. So that's exciting, but also working to improve our pasture lands and rangelands to have these types of systems in them where we can also cultivate livestock too. That is another option there. So basically, in order to start, thinking about how we can improve this, we have to promote agricultural practices that create social, economic, and ecological resilience. And all of these in turn will lead to better human health as well. So we know that resiliency is the capacity to recover quickly from difficulties such as flooding or drought, or in a human, the ability to recover from illness or an injury or something like that is going to be deemed a resiliency. And so we often call this resiliency or sustainable system. We define it by a three-legged stool, always taking into consideration environment, community, and economics. So as a producer, when we take all of these things into consideration when we're making plans within our business, it gives us the capacity to think resiliently and allow ourselves to be set up in a way that we can easily recover if we face trials and tribulations, things such as COVID-19 that we've all been going through, and allows us to pivot more easily in these types of scenarios so that we can stay viable as a business. So what exactly does this mean for the future of agriculture? It means that we have to stop taking a reductionist approach. That approach has basically oversimplified very, very complex biological processes to the point of minimizing and distorting them to where they don't work. So the promotion of chemical inputs has reduced the soil's natural functions and created reliance on external factors. So it's now time to start looking at systems holistically instead of in that reductionist perspective, and instead of focus on high yields, also focus on how foods taste and how it affects the environment in the way in which they're being produced. So we want to make sure that our systems can regenerate and take us far beyond the 60 years that is projected if we keep farming the way we're farming now. So luckily, a lot more people are becoming aware of this need. And for example, a lot more people are looking at soil microbiology. And that was rarely even considered before 1990, even though soil microbiology makes up 95% of life on land. And so, as I mentioned before, most of that life is in our soil, and that microbiology is going to help with creating soil structure and producing soil nutrients and helping the soil hold more water so that we can tolerate droughts and floods more efficiently and control disease. So that's wonderful that many people are doing that, and we need to continue on with this. So another way to improve soil health is to focus on continual live plant, live root in the ground. And as I was mentioning, especially when we were looking at that picture of the perennial system, those live roots, as you can see in the picture on the right, those roots that are coming down are exudating the carbon-rich liquid that comes out of those roots from photosynthesis. And then the middle category, the middle image is actually the arbuscular mycorrhizal fungi that's living in the soil. And it begins to wrap itself around those roots. It takes in those exudates, and it also gives the plant different micronutrients. So you can see that mycorrhizal fungi also has its rhizomes, its rhizosphere going out towards the rock material in the soil, and it's mining nutrients from that parent material in the soil. And it's making things like cobalt and iron and molybdenum and all of these little tiny trace minerals that are so very important for our body. It's taking those and giving those back to the plant. So additionally, those exudates are going to promote aggregate formation in the soil, and that's going to help create pore space in the soil for water to be held and for air to be exchanged and for there to be a nice aerobic system working between all of these plants and microbes. So these two pictures here are basically on the left, rhizobial bacteria, and on the right, the mycorrhizal fungi. So the rhizobium is a nitrogen-fixing bacteria, and I know that y'all probably heard a little bit about this over the past 2 weeks, but those nitrogen-fixing bacterial symbiotes are going to take nitrogen from the atmosphere via the plant and allow that to then be deposited in the soil, which is wonderful. And so we're going to find that symbiosis happening in legumes and the soil. And those nodules that you see there are what we're looking for. On the right, the mycorrhizal fungi is very similar to what I was just showing you in the previous picture. It's exactly the same thing, but this is what it looks like in real life rather than a cartoon. So similar to agriculture, as I mentioned before, we've taken a reductionist approach in how we study human nutrition. And we're always looking and honing in on specific nutrients. As you can see, a lot of people are taking supplements of one single nutrient rather than eating a very healthful diet. And they're kind of substituting a healthful diet with supplements. And unfortunately, this is very much a reductionist approach again. So it's important to look at the whole food matrix, and we have to look at how foods work synergistically with one another and all the other chemicals that are circulating in our body and how those things interact. And so we have to remember that every single thing that we put in our body is a messenger, and that we're constantly regulating and modulating the activity of our subcellular networks through the things we consume. So for instance, we can take our morning cup of coffee. That's going to increase our adrenaline and get us going for the day, and increase our ability to focus and concentrate. And then again, our happy hour cocktail in the evening is going to downregulate and increase relaxation and things of that sort. So those are two very, very not so subtle foods that we take on a daily basis, but every food has that effect. So for instance, broccoli for people who are hypothyroid can actually slow the thyroid down even more. And so people who have an overactive thyroid, such as Graves' disease, it's good for them to eat broccoli because it will slow their thyroid down. But anybody who's suffering from hypothyroid should watch out with cruciferous vegetables. So, very subtle effects that we don't always know what's going on. Okay, so moving right along here, there are solutions, and like I said, these are becoming better understood and adopted by both conventional and organic agriculture producers around the globe. And these solutions are going beyond sustainable and are often defined as regenerative ag practices. Whoops, didn't mean to do that. And so with these regenerative ag practices, we are looking to build resiliency through creating healthy soil that can produce high quality, nutrient-dense food while simultaneously improving rather than degrading the land. And the 5 soil health principles are a great foundation to begin practicing regenerative agriculture. So those are keeping the soil covered, increasing biodiversity, minimizing soil disturbance, and having continual live root in the ground. If you can integrate livestock, that's also a wonderful thing to do, but obviously not possible in every single scenario. So we need to look at different production practices and do these production practices from a holistic view. And so many people are choosing to do this for various reasons. It might be economics. They want to increase their carrying capacity and have more livestock, and so they want to improve their land's resiliency. They might have some health issues that they want to address, and they want healthier food, environmental concerns, succession planning. Some people realize that their land is just not going to be productive for their children, so they want to change what they're doing so that it can be. And increasing production or carrying, well, I already said that, increasing carrying capacity. So these are some examples of how you can go about doing that. So adaptive multi-paddock grazing and cover cropping. Adaptive multi-paddock grazing with animals, cover cropping with multi-species cover crops, conservation tillage practices or no-till practices, cultivating biodiversity through crop rotations, and then reduction or elimination of chemical inputs. And I'd like to just, well, actually, I'm going to skip this because I'm running out of time here. So I was going to talk a little bit about glyphosate. Overall, glyphosate is an antimicrobial. And when we're putting it into the soil, it kills off all the microbes in the soil, but it does the same thing in the gut. And I really do believe, as a nutritionist and what I've seen over the past 20 years, that we really need to take this into consideration. A lot of countries have banned the use of glyphosate, including Mexico recently. And I really do think it's having a big effect on our GI tract health. So while I'm not going to go into too much more of that, any use winds up in our water supply. When we put it on the ground, it is a water soluble component and goes into our water supply. And 75% of the water on the planet is now contaminated with glyphosate. So it's very hard to avoid it. So our best practice is to try to eliminate or reduce the use as much as possible. So how can we do farming practices that are going to help improve nutrient density? I'm going to talk about a little bit of those right now. And overall, it's hard to compare conventional and organic nutrient content. And that's because there's a lot of context that happens within those types of studies that creates massive problems in replicating studies. But what we do know is that soil characteristics are a significant indicator of nutrient density in foods. And we know that soil organic matter can increase available trace nutrients due to improved cation balance and mutualistic plant microbial relationships. Also, soil microbial activity and rhizosphere organisms are known to play an active role in improving nutrient bioavailability and plant tolerance of heavy metals, and that can be disrupted through tillage. So when we don't till, we have greater capacity for that to happen. Additionally, we have species or cultivar specific differences which affect selective uptake and nutrient transport mechanisms. And so modern cultivars, especially like of wheat, for instance, that are focused on high yield, often have decreased nutrition content in them in comparison to older cultivars. So we want to make sure that we select cultivars that have more nutrient density in them. So high rates of fertilizer and irrigation can cause a decline in some nutrients as well due to a dilution effect. And so even though rapid growth can occur, other nutrient deficiencies will be masked. So this, for instance, happens when we use high rates of nitrogen fertilizer, and it will limit calcium uptake. So those foods will have less calcium than if they were getting regular normal nitrogen that was being produced in the soil. Also, plant-specific compounds, or that nutritional dark matter that I was talking about, increase with organic practices. We know that for sure. Those studies have been proven that no matter what, organic foods have more phytonutrients in them. And those phytonutrients all have specific health benefits for us, even though we don't know what all of them are yet. We know that they do supply beneficial health effects. So choosing organic, you'll automatically get more of those plant secondary compounds. Also, chickens on organic feed have shown an enhanced immune reactivity and have a stronger reaction to immune challenges than chickens on conventional feed. So overall, these are important things to think about when you want to produce nutrient-dense food for your clients, and taking these things into consideration in your production practices can be very helpful. So what can we do as consumers? Overall, we can actively engage with different organizations around us to help change some of the laws that we have around our foods, or to help promote and benefit certain things. For the Farm and Ranch Freedom Alliance is an organization that does this. And right now they're working on soil health legislation that would help kind of create better soil health in Texas overall. But they do a lot of other things too. So I recommend engaging with that organization. First and foremost, if you can buy organic foods as much as your budget will allow, that is a very helpful way to change things. We vote with our dollars, and so the more that we buy organic foods, oftentimes the more we can bring down the price. So another thing is just eating a lot of different types of foods. That's going to help you with your health a great deal. So if you can eat a variety of at least 30 different foods per week, you're going to be way ahead of the game in terms of getting a wide spectrum of nutrients from the food matrix. And then buying regeneratively raised animal products and produce from local producers just helps environmentally, and it supports a system that's working to create more healthful foods and more healthful environments too. A new movie just came out called Kiss the Ground, and this is a beautiful movie about regenerative agriculture and its effects. It's the profound effects that it can have, and I highly recommend that you watch it and tell your friends about it. Practice the 5 soil health principles on your own property, and that includes not spraying glyphosate or other herbicides on your own property as well. Compost your food and yard waste. That's a huge factor in nutrient density. If we can get that compost back into the soil rather than going into the landfill, we are taking those nutrients and putting them back where they belong. And we really need to focus on that. So some cities have compost programs. So if you live in San Antonio or Austin, you can compost your food right in your yard waste bin, or if not, maybe starting a small compost pile in your yard. And then eating wild foods whenever safe and possible. There's a lot of different microbes on those wild foods that just exist in those wild environments, and those can be helpful at building our soil, our gut microbiome too. So in conclusion, there's broad evidence for links between soil health, plant health, and human health. And they're starting to emerge in the literature, but much still remains unclear. So a better understanding of how to optimize biological nutrient turnover in organic systems so that we can balance nutrient availability and carbon sequestration, crop productivity, and plant health is needed. We've got to do more research, but overall, we know that we can make some differences by doing the practices that I mentioned today and try to improve human health overall. So as agricultural producers and food consumers, we have the ability to be influencers, and through better agricultural practices, we can create a better quality of life by improving nutrition and reducing disease. So if you are a producer and you have some type of social media platform and you can talk about these things, if you feel comfortable, sharing that you're trying to do things differently, that helps. It helps create a movement. And we also vote with our dollars. So making sure that we choose things that help promote the systems that we want to see grow is very, very helpful. So that is all that I have for you today. I do have a couple of resources here. atra.ncat.org has a ton of publications, videos, tutorials, etc., that will allow you to learn how to do more sustainable and regenerative practices in your operation. And then the bionutrient meter is an interesting website to look at, and they're actually calling for consumers and producers to test some of their foods with this little nutrient meter and give back that data so that they can look at food nutrient density. So I can be reached at kara.k@ncat.org and or reached at this phone number, and I would love to answer any questions.
And we have questions. And once we get done with this, Kara, would you mind putting not only your contact information, but also those 2 web addresses in the chat box? They stay there a little longer.
Okay, yes, I can do that.
Thank you. Let's start with a question from Mr. Rivera. What are alternatives to glycosides and Roundup?
Okay, glyphosate and Roundup are the same thing. So glyphosate is just the technical name. And, alternatives are changing your mindset, right, around what we consider bad and what we consider good. So that would be my first response, is that oftentimes we want to look out and we want to see, a monoculture and, in our lawn or something like that, or maybe in our pasture. And what we found is that a monoculture does not create very good soil health, and we need diversity in those systems. So in general, it's changing the mindset, but it also is about looking at other ways of doing things. Sometimes when we see weeds in a pasture, we become freaked out, but a lot of times we'll see those things change over a period of time because plants are in succession, right? So initially we'll have a lower succession plant arrive, and within a season that plant will go away, and then grasses will begin to come up if you're looking at a natural environment. So we can easily get freaked out about something, but sometimes we don't have to freak out about it too much. Now, in a farming environment, that's very different. And so cover crops are one way to help eliminate the need for weeds. Eliminate weeds coming up. They take up the space and where weeds would come up in between seasons, and then you can cut those down and, drill your seeds directly into that, or, do a light disking. So those are some of the other alternatives. And there's many more, but it would depend on the system that you were looking at.
Okay. Could there be a potential connection to dark matter and potential new pesticides or herbicides? What kind of industry would you study to find out this information?
So I'm not sure that I completely understand the question, but I'm thinking that so when plants have a lot of phytonutrients in them, that nutritional dark matter, it allows that plant to be stronger, right? That plant is using that phytonutrient as a way to protect itself in some way. So a lot of times those plants are just stronger, and that allows the plant to not need to have the pesticides, to kill off invaders and things of that sort. So now, if you're wondering about how some of those phytonutrients could actually be used as pesticides, I really don't know, but I think it's a very interesting consideration. And, we use things like neem oil as a pesticide, and neem has those phytonutrients in it that helps kill off things. So neem and garlic and lavender, all of those things are phytonutrients in those plants that are acting as the pesticide or herbicide. But I don't have a whole lot of other research on new things that are being created out of those plant secondary compounds that are kind of coming online more intensely.
Okay. So Keisha, maybe you could contact, email or call Kara, and y'all can talk it out.
Yeah.
Here's another question. If a farm can only change one or two things, I think we're talking about those 5 principles. Where's the best place to start?
The best place to start is keeping the soil covered, always trying to keep something on top of the ground. Now, cover crops are great, but if you can't supply a cover crop, then even like putting hay or wood chips or some type of mulch on top of the ground would be helpful. But that continual live plant in the root that occurs from a cover crop really feeds that soil microbiome. If you don't have continual live plant root in the ground, you're just not feeding those microbes, and they go into, they senesce and they go to sleep. So it's really important that you keep those active and keep them functioning, because they're doing all the work down there. So I would say that keeping the ground covered and continual live root in the ground would be the 2 most important ones.
Great. Do those principles work differently for farmers on very small acreage as opposed to bigger than an acre?
Yeah, it's going to be harder to do some of those things, kind of depending on your capacity, right? So some people might not choose to plant a cover crop because they don't have what they need to terminate it or something like that. So yeah, it's going to depend on the tools that you have. And but overall, those can be done on large or small acreage, and they're going to be helpful no matter what size your operation.
All right. Now, are there different vegetables or different products that you can grow to kind of target what the needs are in the soil? Or are there vegetables that just cover a lot of the nutrients that might be needed?
Well, obviously, growing legumes is going to allow for nitrogen to develop in the soil, and certain plants also are going to, just based on their root structure, right? They're going to contribute more carbon into that because of their root structure and how that's how that develops. With regard to, I don't know the answer to our specific, when a plant dies, that's how specific vitamins and minerals are going to wind up back in the soil. Mm-hmm. You can look at plant tissues. You could study like plant tissues and look at what their nutrient availability in their tissues are, and how that will wind up back on the soil, and if they are allowed to decompose back on the soil. So a lot of research has been done around that with regard to weeds, like in a pasture environment. Why do we have a strong year where, plantain comes up, and what is plantain putting back down on the soil as it mines nutrients from below ground. But I don't know as much about that with regard to vegetable crops or things like that. But I'm sure that information's out there somewhere.
Just a little more research. Last question.
Yes.
Are there tests to check a gut's biome?
So yes, there are tests for looking at the gut biome, and there's different ways that you can go about doing it. In general, it's a fecal test, right? So it's a stool sample test, and there's lots of different types out there, and I think that they've probably developed even further. I haven't really been practicing nutrition in the past 4 years or so, so I know that they've developed even more, but there's stool samples, and then there's also organic acid tests. And organic acid tests are not typically given by a lot of doctors. It's kind of more of an alternative nutritionist approach. And that's not directly looking at the microbes themselves, but it looks at the organic acids that are produced in our body by the breakdown of different metabolic processes. And sometimes by way of looking at those organic acids in the body, you can see what's going on microbiologically. And so in general, yes, those two tests would be the main way to go. But there's others as well. You can do like blood candida tests for an overgrowth of Candida albicans, which is a fungus that we don't really want a lot in the body. So yeah, there is ways to test that.
Okay, thank you. That's all of our questions. Thank you as always, Kara. This talk that you do is, between your experience and your research, it's so amazing, and I'm so glad you got to share it with us.
Thank you. I'm very glad to share it. And those were all really good questions, as y'all made me think about some things. So I'm gonna look into some of those questions that y'all gave me. So thank you. I appreciate it.